Assalamualaikum and hi everyone. Let's continue with part 3 on our topic numeric data. In this part, we are going to learn about increment and decrement operators. Increment and decrement operators. Increment is the plus sign, while decrement is minus. These operators use only one operand, meaning only one number. For example, if we have count plus, that is exactly the same as if we write count equal to count plus 1. What happens when we do count plus is the original or initial value of count is added by 1 and count will contain the new value. Plus is increment, so it adds 1 to the number. Minus is decrement, it subtracts 1 from the number. Increment and decrement can be used pre or post, meaning that either we want the original number to be incremented or decremented before it is used or afterwards. For pre-increment or pre-decrement, the original value will be added or subtracted by 1 before it is used. In post-increment or post-decrement, the original number is used first, then only after that, the increment or decrement would happen. To understand this concept, let's look at this simple example. We'll start off with pre-increment. Say that we have int x equal to 0. The first print line is displaying the initial value of variable x. Next print line is the pre-increment because we have plus x. And the last print line is displaying the new value of variable x. What do you think will be the output when we run this code? The first print line will display initial value of x 0 because we initialized x to 0. When we do pre-increment, that means we add 1 to the original value of 0 before we display it on the screen. So that's why when we have pre-increment plus x, it will display 1, not 0. As x has been reassigned the new number, when we print out the last print line statement, it will display value of x is 1. Similarly, for pre-decrement, it will display the initial value of x as 0. Pre-decrement is minus 1 because 1 will be subtracted from the original value of 0 before displaying it on the screen. And the new value of variable x is now minus 1. Now, let's look at post-increment and post-decrement and see the difference from pre-increment and pre-decrement. Similar code as before, but here we use x instead of plus x. What do you think the output that we will get when we run this code? As shown in the output box here, we will get initial value of x is 0. Post-increment, x is also 0. But when we print the value of x in the last line, we will get 1. Why do we get x equal to 1 only at the last print line statement? To make it simpler to understand, when we are doing x will only be increased by 1 after x statement is evaluated. So when it is printing it, it hasn't increased by 1 yet. So, to show the post-increment concept in another kind of code, x is similar to if we do int x equal to 0, system.out.println initial x, then display the original value of x. Then on the next line, we have x equal to x plus 1, which means that it will increase the value of x by 1. That is exactly the same as the one highlighted in green, which is doing the increment x plus. The same goes for post-decrement, where when we print out the value of x minus, it will display the original value, which is x equal to 0. Only on the next print line that x is shown to have decreased by 1, so the final value of x is minus 1. In all increment or decrement operators, when we do x or plus x, both means x is equal to x plus 1. The same goes for x minus and minus x. It still means x is equal to x minus 1. The difference is when we have the plus plus or minus minus at the back, meaning that it is post-increment or post-decrement. The original value will still be used at the current time. The newly incremented or decremented value will only be used after that x plus plus or x minus minus statement. In pre-increment or pre-decrement, the original value will be changed before it can be used. Let's look at another example on increment operator. Here we have int I equal to 10, int new num equal to 10 times I plus plus. What do you think will be the output of new num? And what is the last value of variable I? We will get new num equal to 10 times 10 equal to 100. Because we have I plus plus, I is increased by 1 after the calculation. So the final value of I is 11. This is exactly the same if we write it as int new num equal to 10 times I, which is 10 times 10 equal to 100, and on the next line, I is equal to I plus 1. What about the other one? Int I equal to 10, int new num equal to 10 times plus plus I. What is the final value of new num and variable I? We will get new num equal to 10 times 11 because I is incremented before the multiplication. So new num is equal to 110 and I is 11. This is the same if we write I equal to I plus 1 and then the next line do the multiplication, which is int new num equal to 10 times I. Assignment operators can be combined with arithmetic operators, including minus, multiplication, division, and also modulus. For example, if we have num plus equal count, that is exactly the same as num equal to num plus count. Both of these have the same result. The plus equal is basically to simplify the process, as we do not need to repeatedly write the variable again. Other than plus equal that we have seen in the previous slide, the same goes for other operators such as minus equal, multiplication equal, division equal, and also modulus equal. It depends on which way you prefer to write your code because the calculation is exactly the same, only the way of writing it. However, you have to be careful when mixing with other kind of arithmetic operations. For example, say that we have int count equal to 0, and then we have count times equal 1 plus 2. Is that the same as count equal to count times 1 plus 2? If we run this code, the first one will give us the output of 0, and the second one has the value of 2. Why do you think we have these values? In the first one, when we do count times equal 1 plus 2, as we learned previously, it will solve the right side first. So this is basically count equal to count times in parentheses 1 plus 2. The second one, which is count equal to count times 1 plus 2, is evaluated according to the precedence rule, which the multiplication first and then the addition. So just to recap again, the right-hand side expression is evaluated first, then the result is combined with the original variable. If say that we have result divide equal in parentheses total minus mean modulus number, that expression is equivalent to result equal to result divide by in parentheses and then another parenthesis total minus mean and then modulus num. Take note of the parentheses where total minus mean in parentheses will be evaluated first, then the modulus, and only finally the division. The behavior of some assignment operators depends on the types of the operands. If the operands to the plus equal operator are strings, the assignment operator performs string concatenation. The behavior of an assignment operator plus equal is always consistent with the behavior of the corresponding operator plus. Let's look at this example. We have a variable called sentence and has the value hello. Then we do sentence plus equal world, meaning that it will add the word world to the existing word hello in the variable sentence. So it will display hello world. If our variable is type int, for example, when we have int number equal to 5, then when we do number plus equals 6, what happens here is number will become number is equal to number plus 6. And we know that the initial value of variable number is 5. So it will do the addition of 5 plus 6 and give us the output as 11. So based on these two examples, we can see how plus equal or addition behaves depending on the data type. When all operands are floating point numbers, we will get the result also as floating point numbers. Mixed expressions. What would happen when our operands or numbers are of different types? For example, 2 plus 3.5, or maybe 6 divided by 4 plus 3.9. When we have at least one floating point number, or decimal point values, we will get the result also in floating point. Integer operands yield an integer result. For example, 2 times 3 is equal to 6. Floating point numbers yield floating point result. For example, 2.0 times 3.0 is equal to 6.0. If both types of operands are present, the result is a floating point number. Let's see another example. Say that if we have 2 times 3.0, it will give us 6.0. The same goes if we have 2.0 times 3. The result is 6.0. Precedence rules are followed the same as before. It does not matter whether we have integers or floating point numbers. This means parentheses will always have the highest priority, followed by multiplication, division, and modulus, and finally plus and minus. Basically, for our understanding, we can assume that if we have int and int, the answer will be of type int. If we have int and double, we will get type double. The same goes for double and int, it will give us double. And obviously, if both are of type double, the result will be type double. Let's look at this example to recap what we have learned. In this program, we named our class as rectangle. It has a main method. Then it declared 3 variables of type double. Since it declared it within one line, we use comma, not semicolon. We have double length, comma, width, comma, area. Then we initialize our variables by writing length equal to 3.4 and width equal to 5.5. The last two lines are our system.out.println line. We want to calculate the area and display the word area followed by the calculated value. So we use the plus sign to concatenate them. Since we want the length to times with width, we write length times width in parentheses to force it to be done first. What do you think will be displayed if we don't have the parentheses? Without the parentheses, it will still display exactly the same result as before because of the precedence. Multiplication, or the asterisk, has higher priority than addition, or the plus. So the multiplication will always be carried out first before the string concatenation. And the last line is calculating 2 times in parentheses length plus width. The output that we will get when we run this is area 18.7, perimeter 17.8. To summarize, in this part we have learned about increment and decrement operators, which is the plus plus and minus minus that can be either pre or post. We have also learned about other assignment operators that can be used to simplify the way we write our calculation by using plus equal, for example. That's all for this part.